Hey everyone, how's it going? We will be doing a review of OpenAI's challenge, Parameter Golf, today. A little switch over from our PyTorch adventure, though don't worry, this is still PyTorch, so it counts. It's still PyTorch. It counts. We're going to read through Parameter Golf Challenge from OpenAI, and we're going to see what it is, what it looks like. We're going to read through the code, and we're going to find out if we want to maybe give it a shot or have some ideas on ways that we can maybe even enter the challenge. I think we probably could. I do have some ideas. Though they want us to have 10 H100s, which is not a cheap proposition. We could do it though. We could do it. And there is a low scale version that allows you to test locally, which we will be testing maybe potentially locally, though it's still gonna take a lot of compute. So we'll see how this works. We'll see how it works. All right, so OpenAI's Model Craft Challenge, Parameter Golf. It's a challenge to train the best language model that fits into 16 megabyte artifact that trains under 10 minutes on a lot of GPUs, evaluated by compression on the FineWeb validation set, Tokenizer agnostic. Oh, we can use any tokenizer you want. Bits per byte. I don't know what this part means. I don't. Why did they put that part in there? Why bits per byte? What is that? Why did they put this here? I mean, seriously. Anyway, the challenge. It just doesn't make any sense. There's no, of course, there was bits and bytes, right? Depending on what the shape is of your operating system, what you've defined as a byte. A byte could be 8 bits. I mean, what's the point of that? The challenge is heavily inspired by the NanoGPT speedrunning challenge that they did some time ago. This is this is by someone else. Okay. 124 million parameter in 2 minutes. NanoGPT. Okay, this repository hosts the NanoGPT speedrun, in which we collaboratively and competitively search for the fastest algorithm to use 8 NVIDIA H100 GPUs. Hey, how's it going there? Prod by Core, good to see you. Welcome on in. Happy Thursday already. It's almost the end of the week. We're going through today OpenAI's challenge is what we're going to do. One day I'll get in an internship with you, hopefully, in IT. That sounds good to me. Hey, it might happen. You never know. You never know. Someday. Today, though, we're going over OpenAI's coding challenge that they released last week, right? They released it last week. They already have some submissions on the leaderboard. We can see we've got a couple of submissions here that are doing pretty good scores. 1.1 on the loss. So this is the score, right? This is the loss, I believe, for is it the aggregate loss? We'll find out. We're going to keep going through this. We'll figure out what this is like. Competitive to train a model that reaches 3.28 FineWeb validation loss. Okay. As quickly as possible. We're excited to see how optimizing the parameter constrained settings pushes people forward to unique architectures. Test time, compute, aggressive parameter tying, depth, recurrence, low ranking training, compression schemes, low precision, QAT, bitnets, novel tokenizers, and the creative submissions tests to time training, long contexts, mega kernels. Ooh, and a bunch. This is the one I like. I like mega kernels. I think that one's a pretty fun one. All right. So, where are we? Okay. So let's keep going through it. Keep going through it. If you're familiar with neural scaling laws, you can consider this challenge a form of L of N optimization, where the objective is to optimize the lowest loss given a fixed number of parameters, unconstrained by data, compute, steps, or architecture. Okay. Challenges like the NanoGPT speedrun, which we just looked through just a little bit ago, which optimizes for a form of L of T, so the lowest time, right? With time given, time constraint to the loss. So how fast can you get to the, 3.28 loss? How fast can you get there? Can you get there in 2 minutes? If you get there in 2 minutes, wait, do they have a leaderboard? Who did it? What was the fastest? They do have a leaderboard. All right, what's it? 45 minutes. Oh, it goes even. Oh, was it? Look at this. It was 2 minutes. All right. Wait. Why are these low? Record time 45 minutes? Doesn't that seem like that's worse? The 3.28 target was selected to match. GPT too small. Okay. Look at these lower ones. Why are they ranked lower though? It keeps going down. Oh, minutes. Oh, did they get below minutes? 77? That's crazy. Replace partition to hyper connected with single saved activation. Okay. Hey, Mark Lemon, good to see you. Welcome on in. Thank you for clicking the hello button. Good to have you here. Today we're going over OpenAI's coding challenge. It's still PyTorch, so it counts. It's still PyTorch. I'm just curious about this. So it was inspired by this coding challenge. The modded NanoGPT is a speed run in which we collaboratively search for the fastest algorithm to train language models that attain at least a 3.28 cross entropy loss, okay, on the fine validation set. The target, okay, the speedrun code descends from LLMC's PyTorch trainer, which itself descends from NanoGPT. Hence the name of the repo. Okay, modded NanoGPT. So they essentially want us to, in this challenge, get to 3.28 cross entropy loss as fast as possible. And the winner, it looks like, is right here. Where's the winner? Around here somewhere. Right here, okay. This person. Classic Lardy. Larry D. Classic Larry D. Okay. That was that. Now, we're going to look through OpenAI's version of this, which is not a speed run on time. You have a constrained time limit of 10 minutes. So, let's keep going on this. Loss a fixed number of parameters. So you have a fixed number, the lowest loss given a fixed number of parameters, so you can't change the number of parameters. Constrained by the data, so you can't change the data. You can't change the compute, the steps, or the architecture. Wait. Hold on. Wait. Okay, wait. You can consider this challenge a form of L of N optimization, where the objective is to optimize the lowest loss given a fixed number of parameters. Can we change these things, or are they fixed? That's what I'm wondering about. The challenge like speedrun to optimize for L of T, this optimized for L of D, lowest loss given constrained data size, can be thought of as an equivalent challenge in this family. Okay, so definitely we can't change the data. I know that part. We can't change the time limit. That's 10 minutes. It says we can't change the architecture. So if we can't change the architecture, what else? And we can't change the steps or the compute. Well, the compute is constrained, right? Eight NVIDIA's processors. So let's keep on going. We also know compute is expensive, so OpenAI is sponsoring $1 million in compute credits to help people get started training their models. And you can request it. How's it going there, Paul? Thank you for saying hi. Thank you for clicking that hello button. Good to have you here. We're going through OpenAI's coding challenge today. We're going to see what it is. What are the rules? Like, we only get 8 H100s, which is a lot. It's a lot of rules. Hey, New Start, thank you for saying hi. Thank you for clicking the hi button there. Good to have you here. Welcome on in. We're going to read through the coding challenge, and then we're going to read through the code. And then we're just going to get familiar with it, and then we're going to riff on some ideas. We might pull out some ideas. We'd love to see new submissions that don't meet the compute limitation requirements in the non-recorded submission section. Okay, so they are accepting outside the scope of the limitations that they've set. However, they don't count. They don't count. You get maybe some notoriety, but they don't count. All right, we're excited to see people push the infinite frontier of parameter limited performance as well. Okay. We also know compute is expensive. All right, so we just read through that, right? So they're going to give us, we can request a compute grant if we want. When requesting a compute grant, please make sure you choose the appropriate level, write sufficient justification, and submit an email tied to an OpenAI account. Okay. So if you want, they're going to give you the compute for free, which is nice. Fill out the form. It helps us attribute a challenge to the submissions, reach out about opportunities. Completing this form is not required to participate, okay? Many researchers at OpenAI first distinguished themselves through elite mathematics and programming competitions. The Model Craft Challenge is designed in that spirit, testing the ability to tackle unfamiliar problems with creativity and rigor. Qualities we believe are essential for a frontier AI researcher. What do you get if you win? That's my question, right? What do you get if you win? In June, we plan to hire a small cohort of early career researchers. Targeting current undergrad students and recent graduates, including Olympiad medalists. Hey, thank you for the heart. Appreciate it. Elite competitors. Wow. Okay. So they're looking for top talent here. And apparently, if you're a student, you're better off. Well, I guess I'm disqualified. I'm a little bit beyond college at this point. For exceptional participants, the challenge may also serve as ways to stand out to OpenAI researchers and recruiters. Okay. As far as I can tell, this is just hey, you might get an interview with us if you rank on the leaderboard. That's it. That's all I'm seeing here. That's all you get. The challenge runs from March 18th, which was last week, to April 30th. So you have 1 month. You have 1 month. You get 1 month. How's it going there, Running Gaming? Can we train a FP8? I think so. I think we can. Yes, I think so. Maybe. Because look, we're able to change activations. We're able to change legal score first, TTT, which is that trip? What is, I don't know what this is. So this is the current leaderboard here. PR number 549. So how you do it is you submit a pull request. So let's look at their pull requests here. Pull request 549. Where is that at? All right. Wow, there's already 1,000 pull requests, you guys. 549. All right, here's the number one winner. Here's the winning. Here's the top of the leaderboard so far. They merged it? What do you mean it merged? wait. It merged the. How do they do this? What files changed? Let's look at this really quick. Leaky ReLU. Where is this at? What directory is this in? Oh, records. Okay. So you've got the logs and you've got the updated. So let's look see this real quick. 3 seed mean STD standard. Okay. So here's all the parameters that they used. So you can change the parameters. Okay. So you might be able to do FP8. I don't know. I think so though. We're going to find out. Chunk size. TTT hyperparameters. Backward looking. Let's read through some of the code. I want to see what the code looks like. All right, so this is a log. Here, load the diff. This is what I want to see. Okay. So they updated the train GPT Python file. And they changed it. So it looks like they're using bfloat16, which you want with ReLU, right? With ReLU, you want to use bfloat16 because you're going to get more bits in the floating point number for precision. What I'd like to see is sort of what they changed. So what I'd like to do is let's download the repository and do a diff and see what changed. What's the difference? Torch no-grad step? Why would they do a no-grad on the step? Tokenizer. Tokenizer evaluation helpers. Build sentence. Interesting. Okay. So this is the winning. So far, this is the number one on the leaderboard winning position. Int 8 keep float max Numel. Howdy, how's it going there, Bonzupi? Welcome on in. Good to see you. Competing for 1 million USD. Oh, no. I know. Wouldn't that be great if they did? No. You don't get anything. You get nothing. If you get to the top of the leaderboard, the best you get is an interview. That's all we saw. I know. Wouldn't that be great, Anthony? Wouldn't that be great if that was the case? No, it's not. It's definitely not. That is not the case, unfortunately. Where is it? They did say there is. OpenAI is sponsoring a 1 million in compute credits to help people get started training their model. Basically, they're going to pay for your GPU to rent it. You don't. They're not going to give it to you. You get to rent a server. That's it. Interview, which you can fail in theory. Exactly. Right. Exactly. You could do the best. You could be number one on the leaderboard, and they give you an interview, and they're like, "Man, you're fine. You're good. We don't want to. You lose. You lose." So it's not really like the most rewarding challenge of them all, though. It's still going to be fun to look through and read. Because what I want to do is I want to read the train GPT Pi. Let's go through step by step each parts and components of it, so we can understand what's going on inside of there, and then we can come up with some ideas on how to make improvements. 4K sequence link input. This feels like a cheat to me, doesn't that? This is 2K sequence length, which is interesting. Int 6 mixed precision. That one's neat. See, this one's novel. I like this one. This is a good idea right here. Changing. Okay, so all right, so we found out the answer. Running gaming, yes, you can change the type of bits that are being used with each of your parameters. You can do it. All right, so we found out what the answer is. Yep, because we're reading through the leaderboard. We're learning all the things today, aren't we? Steven, let's go in there. Dekif, good to have you here. Inspired by you, I have started to Twitch stream. Nice, you did all right. When I studied data science. That's a good way to do it, because then you can explain to yourself. This is kind of what we're doing right now, right? We're learning as we go, and we're talking live, and everyone can chime in. You want to know of a low CPU intensive screen sharing software to share my screen on Twitch like you on a MacBook Air? Oh, yeah, it's easy. All right, Better and Better Dan is my Twitch. Oh, Better and Better Dan. All right, that sounds great. So you've got your Twitch user. You're good to go, and you're looking for a low CPU intensive screen sharing software. The lowest that you get is OBS, right? So you get OBS right here. That's the best one there is. It's just OBS. There's also, and what you can do is, I think you can turn off the preview to, or reduce the preview here, so that way it even lower CPU further, so it's less compute while you're streaming. There's also Streamlabs, which helps. So OBS/Streamlabs, which is just a fork of OBS, right? So those are two options. Streamlabs has a pay option. So there's money involved. You have to pay potentially. Unlimited compute leaderboard and non-recorded submissions. You can do a 1-bit quantization, and apparently that doesn't count. That is off the leaderboard. It doesn't count. Roger that. Steven, thanks. You're welcome. Absolutely. All right. So let's see here. Many researchers, June. All right. So happy training, you guys. We read through. Thank you for the heart. Appreciate it. We read through the intro. We looked through the leaderboard really quick to see what everyone kind of did. Now let's see what you need to do to submit. Breakthrough ideas. Let me zoom in here so we can see this a little bit better. Breakthrough ideas are rarely immediately state-of-the-art. Instead, they're developed slowly. Bro, what are you doing today? What is the objective? Oh, today we're going through OpenAI's coding challenge. That's the plan for today. We're going to look at it. We're going to understand it. We're going to read through it. And then maybe we'll start thinking of some ideas on how we can submit and make it to the leaderboard. Wouldn't that be great if we made it on the leaderboard? We don't have to get I would love to get to number 1. I think it would be great if we could at least make our way towards that somehow. Doing something with AI? Exactly. Visionary. You know it. Visionary doing something with AI. You got it. First demonstrating signs of life, iterated on, then only ultimately optimized on the systems side. Don't get discouraged if a new algorithm doesn't initially beat the best leaderboard. It's okay, because you know what? Your idea, it might eventually do so. It might not run, or even the naive baseline. Okay, so there's a baseline that we have to beat. That is around here. Where's the baseline? Here's the naive baseline. So we have to beat a loss of 1.224. That's what we have to do. 9 layer, 512 dimension, and 124,000. This is the embedding right here. Tied embedding. 4 KV heads. Okay. That's interesting. Well, it's 4 is fine because, you know, you're only doing the embedding like this, so at a 1K embedding. All right. La la la. If you have an idea and you believe in, consider ignoring step times early on. Once you prove you can beat the baseline and the number of steps. Okay, so we have a number of steps. We have a maximum number of steps, apparently, and the same number of steps. You can then start focusing on how to make it fast. Interesting. Okay, so they're giving you some advice here. They're giving you some advice. Open ideas. Stealing ideas. Exactly, Hadar. It's exactly what's happening. They're stealing ideas. They're like, okay, everyone, it's a contest. You don't win anything. You win nothing. You might get an interview. It's a contest, right? Submit your work. Submit your ideas so we can steal them from you. We'd love to see weird and creative ideas in the challenge. I sure you would, since you never know what you may work out in the end. Most likely, these will be a good fit in our unlimited compute leaderboards as non-record submissions. If you submit weird and creative ideas, but they don't quite make it across the requirements, they have a place for you still. We have some requests for what we'd love to see in the implementation. A 1-bit quantization, a ternary quantization. So wait, is that like a 3-bit? A JEPA, a text diffusion. Oh yeah, okay. You know what? They want the text diffusion because they've got some competition there. HNet tokenization, universal transformer. We have a lot of depth recurrence submissions. However, we'd love to see 4-hour. Okay. So they're looking for this mega kernels, which is what I like. See, this is where I'm thinking. Here's my ideas. We need to go beyond just the algorithm itself and think more about architecture and how we distribute compute across multiple H100s, right? If we can come up with a way to better utilize those H100s, not only in a mega kernel, in a way to distribute that load, because as you're invoking operations on those H100s, that latency when you're submitting work is a huge factor. So if you can reduce that latency or eliminate it, you can basically get more compute time compressed into that 10-minute window, right? You can win that way. I think that would be a way to win. Krishna, are you making something like a neuro-symbolic AI like Princeton University did, like Microsoft BitNet C++ ternary interface? Extremely powerful. Maybe. We'll find out. Right now, we're just going over the OpenAI challenge. That's the plan for today's stream. We'll go back to the tutorial. So we've been working on this tutorial here. We'll go back to it. Today, we're looking at the OpenAI parameter golf. That's what we're doing today. A state space model, E2E, triple T, super long context for evaluating or training. Super long context, interesting. Learning adapters on random linear maps. Random, hey, see, that's also one of my other ideas. I like if you introduce more randomization into it, I think we could get a bump there. I think we can get a bump there. We just got to find the right seed so it's reproducible, right? You got to find the right seed. If you find the right seed, you're going to get some reproduction there. Though that would take, some compute that you'd have to just train it for a long time and find the best one. Optimize. Although in that case, it's not really transferable though. If you did it that way, maybe it could be a smidgen. I don't know how transferable it would be, but it might make it to the leaderboard. Training your first model Mac, Apple Silicon. If you have an Apple laptop with Apple Silicon, you set up MLX training script, which they have. I saw it right around here. It was MLX right here. So they've got a dedicated one for running on Apple Silicon. All right. If you don't have a Mac, you can run on an adapted version of the script without MLX support. Just ask Codex to refactor it. Oh, okay. The challenge is straightforward. It may be fairly slow, so we recommend jumping straight to cloud GPUs with RunPod. RunPod must be a company that offers, GPUs. Okay. So this is they're sponsoring. This company is sponsoring. Okay. Hello, bro. How's it going there? Official? Good to see you. Welcome on in. Happy Thursday. We're looking through OpenAI's coding challenge today, which goes for, you've got 1 month. You got 1 month to submit on the leaderboard. And there's already like 880 submissions. There are quite a few submissions already. First, clone the repository to make a fresh Python environment and install the packages needed for the MLX path, plus dataset download. Should we start, you guys? Hey, Savon, how's it going? Quick hi, hope you're doing good over there. Hope everything's okay. We're looking at OpenAI's coding challenge. Not really here. Oh no, that's terrible. Yeah, I've been hearing about it. It sounds really bad. Hi there, how's it going? Good to see ya. Welcome on in. We're looking at OpenAI's coding challenge today. And we got to the point where we're gonna start cloning stuff. Should we get going? All right, let's do it. Let's start cloning stuff. All right, we're gonna do a new virtual environment. Okay, so let's go. Here. No, let's not do this. We'll just open up a new terminal here. cd ... blah, blah, blah. All right, so let's do a clone. We're gonna clone this real quick. Copy. Bro, open source of AI 3D models are there, bro. Wait, what do you mean? You mean the 3D model generators? The AI generators that generate 3D models? They're really good? They are really good, are they? Parameter golf. All right. You know what? I'm going to leave this really quick. Close that, close this. All right, cd parameter golf. Param tmux. All right, there. Nice, fresh, clean window. We're good to go. Yeah, bro, they're really good. Nice. They are pretty good. You know, and you can even see now that we've got really good video generators, really good audio generators. Like just amazing. Phenomenal audio generators. The videos are good, and now you got 3D models. Basically, all the generative AI has gotten amazing. Human level and beyond quality. All right, we got our data. All right, we got it. We got the data. Check it out. All right, let's create a new virtual environment. What are you on about, mate? Mr. Random 54, welcome on in. We are looking through OpenAI's coding challenge, which you have 1 month to submit to. We read through all the requirements. We understand the thing. Now let's read through their code, which is the baseline that we have to beat. Let's make it happen. And we'll try to run it. For a bit. Microslops Copilot, the best one. Yeah, Mike Hawk's nice. You know, exactly. They're so good. They make the best slop. The top slop. Microslop Copilot. It's a good one. It slops the best of them. The best slop. No one makes better slop. Deactivate. Make a new one in the current working directory. Then we're going to pip install. Oh, we need to source it. Source.vn bin activate. Right? And then pip install. All right, Python. So install the latest. Python. Microjeet. Oh yeah, the good old Microjeet. Hey man, how are you doing? How's it going there, Mario Srini? Good to see you, Mario Srini. We're looking through OpenAI's coding challenge today. We're gonna look through every single piece of it. We're gonna try to understand the most we can from it. We already read through all of the guidelines. We read through the entire thing. And now we're going to walk through setting up a machine locally. And then we will give it a try. We'll give it a try. That's what we're doing right now. And then we'll read through the rest of it. So basically, this is like a primer. If you are interested in submitting one of your works, which you could, a candidate, if you want to submit, that's what we're going through today. So we're sort of understanding it, learning it, and then I'll have we went through all of it. We have the answers. We have most of the answers. It's been very tough, constant attacks. Oh no, very depressing every day. Oh no, don't give up, Savon. What's the OpenAI challenge? This is called Parameter Golf. They have a nice little emblem up here at the beginning. Parameter Golf. Give us your best algorithm advancements and we will just copy your ideas. No promise for any reward whatsoever on your side. You will get on the leaderboard, maybe, or you might get an interview with us. That's it. That's all you get. That's the best you get. That's the best of the reward. Myra Srini, I know, right? It's so on brand. It sure is. It sure is. For OpenAI, you got it. You got it. What are you running? Apple Silicon on unified memory. Bonzupi, that's what we'll be doing today. Exactly. That's what we'll be doing today. So we went through all the things. Now we're doing the getting started. And we are going to MLX NumPy, sentence piece, hugging face, datasets, and TQDM. How much RAM? Enough. Your teeth are nice. Mr. Random, we went through extensive orthodonty in high school years. And beyond high school years. It took a long time to get through that orthodontics. Lots of orthodonture. You know it. Orthodontics. You know, the best I could say. Okay, so let's get this going. So Python-m, we're going to pip install -s upgrade pip. All right, so let's get the latest version of pip. We're all good to go. Pip 26, and then we're gonna. Isn't there like a requirements file? Why would? Oh, there is right here. Okay. La 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 la. Okay, so there is a requirements file, so we could install this tick token. I've not heard of tick token. This might be the embedding. Hold on, I need to look this up real quick. Let's look up tick token. It is a tokenizer? Okay. It's a tokenizer. Mr. Random 54, thank you for subscribing. I believe it's the tokenizer. It sure is, Bonzupi. It sure is. It's a I forgot what BPE stands for. I remember learning about BPE. It's like byte pair encoding. That's what that is. It's byte pair encoding. Yeah. Gotta go, Savon. All right. Thank you for stopping on by. Hope everything's safe. I hear that we're trying to make. We'll see how it goes. I don't know if it's going to be over soon. I want it to be though, because it's hurting the world. All right, so we've got our encoder. Get encoding. 200K base. Decode encode hello world is equal to hello world. Got it. All right, there we go. Hey, Sergey, thank you for subscribing. Welcome on in. You joined the right channel for software engineering. Today we're going over OpenAI's coding challenge. We're going to see every piece of it that we can understand. We're going to look through all of it. And we're going to answer any questions you guys have. If you want to submit your code, can you write code that makes guns not work anymore? Oh, Nathan, how's it going? Good to see you. Well, not, I mean, technically yes, but not in the way that you're thinking. I don't think so. They need something after closing Sora AI. Exactly right. They turned off the video generator app. You're not submitting your code to scam Altman. You're not to scam Altman. No way. Good old scam Altman. All right. You don't have to do that. You don't have to do that. You know what? How many people have submitted so far? That's actually the question. You want to know? We've got the answer. Let's see. The answer is right here. Right around here. There it goes. 855. 855 people have submitted. Or thereabouts. I assume there's probably multiple pull requests that are not related. This is the most recent one. Is this the... Yeah, this is the most recent one right here. Results, 1.2 on byte pair B. My brother's wife is a senior software engineer and 26 in Gemini. At 26 in Gemini reached out. They basically said, hey, whatever you're getting paid, we want to add 50,000 if you come on board with us. 30,000 US. 30,000, that's a pretty good one. That's a pretty good salary. Now, most people don't make that salary. That's a really good salary. A very nice salary you got there. That would be, was it a yes? 300,000? Did they say yes? State of the art. Not competitive with state of the art. 3 loop recurrence has never worked before. 900x quantization amplification over 3 cycles. What made it work? 3 techniques, none used elsewhere in competition. Okay, so this is kind of interesting. Capped time scaling, Birkhoff contained mixing, output LN, RMS norm with MLP inputs to MLP output. This was the critical piece. Without it, shared weights can't tell loop iterations apart because pre-norm erases magnitude. With it, mixing alphas learned a clear gradient instead of collapsing. Based at Kim et al. Okay. This is a lot of fancy words, isn't it? Absolutely. How's it going there, Official My Gamer? Thanks for saying hello. Good to have you here. Absolutely. Welcome on in. Microsoft made a 1-bit model. 1 bit? It's 1 bit. It's either on or off, right? There you go. There's your parameter, 1 or 0. You can do 1 bit. 1 bit should work. 1 bit will work. And then you don't need to activate though, right? You don't need to do any activation with 1 bit. You can skip everything if you do 1 bit activation. There's no activation required if you do 1 bit. Gamma survive quantization as floats pass through, while everything else gets crushed to int 8. That's pretty neat. Okay. Possibly useful for non-recurrent submissions. So this is just the most recent submission. Okay. Let's get back to our tutorial here. Not our tutorial, the setup process. All right, pip install. Let's install all the things that we need. All right, that's installing. And then download our cached version of FineWeb with 124 token vocabulary. This will download it? Okay. Let's download it. Downloading. I like the beat. Oh, me too. Hey, Sergio. I like the beat too. Microsoft's one is 1.58-bit ternary. So -1, 0, and +1. 2.4 billion parameter large language model trained on 4 trillion tokens, enabling faster inference and lower memory usage. That's a pretty, I mean, you're getting to the floor at that point, right? So ternary, got it. So you've got 1 bit for sign and 1 bit for 1 or 0. So you've got, isn't that like, that's 2 bits. That's 2 bits. It is 2 bits, right? You can't do it without, it's 2 bits, you guys. It's 2 bits. Yeah, it's called BitNet. Oh yeah, I've heard about that. They called it BitNet 1.58, and it's actually -1, 0, and 1, not just 0 and 1. Which is 2 bits, by the way. That's not 1.58. They did, I remember reading through this. The reason why they can call it 1.58 is because some math rounding, like, it's not real. It's not actually 1.58 bits. Also, your operating system doesn't really let you use 1.58 bits. You need specialized hardware to really consider it. Am I here? Yeah, you sure are, Official Gamer. You're there right now. Extremely efficient on CPU. Ah, yes, because you can do pretty... All right, so what do we get here? We got our FineWeb. All right, that is a 200 megabytes? Really? Oh, wow, no, it's more than that. That's a lot. Okay. For 1.58, we need Quantum 1, a quantum. Yes, we get into the quantum realm. That's when we get real AGI, right? Artificial General Intelligence. Because your brain is a quantum computer. Did you know that? Your brain is quantum. What is the best AI tool on the market now? I heard about Manus from Meta. They're doing well, more than the rest. So the best one, they're all really good now, right? They're all very good, very competitive with each other. I think right now, if you're looking for state-of-the-art, top of the leaderboard, isn't 5.4 with OpenAI currently the best? Also, Gemini is really good too. And it's not, you don't have, it's really low cost or free. Thank you for the hearts, you guys. Appreciate it, Bonzupi. They made some advancements in ternary computing. Oh, did they? They pushed us further. It's crazy how fast we're racing towards 2029 and getting to AGI, and how close we're getting, and the self-improvement approaches that we're using these days. Models are good enough to improve themselves, and if they can get into a self-improvement loop, eventually they can loop faster and faster and faster, and then it just, like, you know, and then we get to the singularity, and then whoever wins gets the super intelligent system. That's when they win. That's when they win, right? Okay. So now we got our data set. This populates datas and tokenizers. By default, this downloads full validation split, 80 for training and probably 20 for testing, right? 80 billion tokens. For a smaller local smoke subset, past train charts 1, for example. Oh, and that will give us a smaller set. Okay. Which we probably want to do. We're gonna. So wait. Let's see. Python, data cache, FineWeb, variation split, train charts 10. Got it. Okay. Let me do train charts 1 instead, because we're not gonna do the whole thing. All right. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. rm-rf data. Let's get rid of that and re-download this with only 1 shard. What happened? Wait, what do you mean? Can't open file? Oh, no such file or directory? What are we doing here? Oh no! Whoops. All right, hold on. Get reset hard. There we go. Ha! No, we're back. Bro, help! Official My Gamer. What do you want? What are you looking for there? Cloud app is crashing so much it's getting frustrating. Oh, it's terrible! Yesterday it was down for 2 hours. Oh no! At my company, we use a private version of it, like a hosted VPC version, so we don't have to worry about that. We have our own. I think somehow we'll end up with something that's almost functionally identical to AGI without actually being AGI. Something next year, if not near in the end of the year. Oh, that would be great. Hey, Claude, welcome on in. Hello, man. Dr. Stephen Strange, welcome on in. Good to have you here. Cumulator, what's the stream about? We are currently looking through OpenAI's coding challenge. If you guys are interested in submitting to the coding challenge, it's called Parameter Golf. OpenAI Parameter Golf. Let me put it over here in our Discord real quick. So under link share, we'll throw this here. Link share. Golf. There we go. This is the challenge. The challenge is you've got 10 minutes on 8 H100s to evaluate on a FineWeb compression validation set. Tokenizer agnostic. Use whatever you want. Yeah, it's pretty neat. I think it's pretty exciting. My courses started. It's hard to follow some courses because some people aren't fluent in your language. Oh, Soki! That does make it difficult, doesn't it? That makes it difficult. That makes it a bit of a challenge. That's going to slow things down for sure. Okay. So there's no reward. If you submit, you get to the top of the leaderboard. Essentially, all you get is notoriety, from my understanding, and a potential interview. Maybe. They're saying you might get an interview. They're not. I don't think they are. I don't think they're good. They just want to steal your ideas, is what they're doing. It's just an idea capture. It's still a lot of fun, though. Okay. Need help on finding open source of AI that generate 3D model. Oh yeah. There are an open source version of that? Open source? I don't have any. Here, I've got you. Go to Hugging Face and go 3D. Go model. There is SAM 3D object. So let's go. There's text generative, and then you can go 3D. See here, strict small 3D, data merge, mem. So here, the idea is you go to Hugging Face /models and start searching, and you want for text generation because it's going to be a 3D model, right? Yeah, bro, nice. Are you planning to switch to OpenAI? What do you mean? Thank you for the heart. Appreciate it. What do you mean switching to OpenAI? We're switching to Torch. We're staying on PyTorch for a while, and this is also PyTorch. Okay, brother. Thank you. Yeah. Hugging Face in light mode. I know. Diabolical. Is there a dark mode that I can do? Because let me see. Where's that button at? Blah, blah, blah. Settings. I'm going to settings. Let me pull this off real quick. Just in case. I'm going to settings. See if we can get theme. There it is, theme. There you go. All right, we got you. We got you. There we go. All in dark mode. There we go. Hey, Drawing Brothers, welcome on. CTO of OpenAI. Oh yeah, I see. I mean, career switch. No, we're good. We're good. We've got our own thing. Yeah, thank you for asking, though. Thank you for asking. Beautiful. There we go, Bonzupi. There we go. Text generation is what you're looking for. Okay. So, now that we've got our data, did we download it? Did that work? Did that work? Oh, it's done. L data get status. Did anything download? Yeah. All right, let's say it did. Let's say it did. All right. Thank you for the hearts, you guys. Good to have you here. Hadar, I tried Hugging Face before. They have a tool giving 3D model by picture. Ooh, there we go. Yeah, that's a good one. What about WW3? What do you think about WW3? Or I think I know what you're talking about, and it's talking about some geopolitics, right? And I don't know about it. I don't know much about it. I'm not looking into it. I hear it about on the news. Cool, bro. Nice. Very nice. All right, let's keep going. This populates data sets. All right, so let's go. L data sets. There we go. Fine, there it is right there. Okay, fine. And we've got the smidgen of it. Okay, so we got, oh wow, it's still a lot. It's 200 megabytes times 2. It's still a lot. All right, so about 300 megabytes there. Now we can run this. I think this will run. Then run a small MLX training job. Validation always runs on the full split, which the fixed first 50K document set. The smoke command above skips periodic validation and prints the loss and the val p BBP once at the end. Okay. Skips periodic validation. So this might take a long time to run then, is what you're saying. Is that what you're saying? I would like periodic validation though. Val loss every. What is this val loss every? That might be 200 iterations. Let's do 1 iteration. All right, let's do this. All right. Let's do 1 iteration. 1. Train batch tokens. And then, I don't know, let's do, 1. All right, we're running it now. There it goes. All right, so it's ReLU. Yep, ReLU. Warm up steps. Okay. We're running it. Progress. Okay. While that's training, let's keep reading. Scaling up to a remote machine. Once you're happy with your local test or you want more compute, switch to a remote CUDA machine. The good old NVIDIA GPUs can rent from anywhere. OpenAI is partnering with RunPod, the sponsor, to make setup easy as possible. You can click Create Run Account. You should also set up an SSH key, the setting tab on the left. We might do this tomorrow. This might be the plan for tomorrow. We'll get some NVIDIA GPUs up and running. Once you've got your account created, the GPU Cloud Pod, you can choose whichever GPU SKU you'd like. Finally, the leaderboard submission must run in under 10 minutes. Remember, on 810H100s, specifically the XMS variant, we strongly recommend testing and running experiments on the cheaper SKUs first, since H8Xs cost 20 hours. $20 per hour, which is, that's a lot of money. That's a lot of money per hour. Although you only need to run the test for 10 minutes, right? Because it's like, that's as much as you get, so. Start on a single pod, which will be 8x cheaper. Deploy using the official parameter golf template. Launch template. Let's look at the launch template really quick. Oh, okay, got it. No. Let's not bother with that. Okay. This is how you do it on RunPod. Got it. On your remote machine, clone the repo on local disk. All Python dependencies are already pre-installed on the image. Because of the launch template. So you just clone the parameter golf, and then you apply your changes, and then you run. Download our cached version of FineWeb. We'll use the 1K token for now. Okay. That'll download the data. The WAN 2.1 open source is best for video generation. Oh, is it? That's the best one? Official Gamer? This defaults to the full validation split plus 80 training on shards on 8 billion tokens. If you only want smaller subset of the iterating, pass the train shards, which we just did, right? We did that, right? Where are we now here? All right, so it looks like we're about 30% done with the small. And that's running locally. The smallest, one tenth. Let's see. Are we running? It's not fully saturating my system. Okay. By default, Train GPT keeps its 10-minute wall clock cap. Oh, automatically it does. Okay, automatically. If you want longer, you can say max wall clock seconds. Explicitly override. Got it. Okay. Good to know. Good to know. This command prints train loss during the training. I would like to see the loss. I really would. I want to see the loss immediately rather than the current progress. Because I want to see if it's making progress, right? That's what you want to do. You want to see if it's making progress. Final 8int zlib round trips. If you want periodic validation logs, thank you for the hearts, you guys. Appreciate it. Well, it's good to have you here. I have an idea. All right, what's your idea, Drawing Brothers? When users input their face, we find the shape of the face. Thank you for the hearts, you guys. Based on the shape, we find similar haircuts. Oh, when you use the GAN to apply haircut for the user image, can you give suggestions? Wait, why are you doing that? What are you doing? Are you trying to like give people different haircuts? Is that what you're trying to do? Bro, it has the open source. Can you guide to install locally? Yes. Hugging Face is going to give you all open source. So if you do and then if you click on a model, what you do is you click use this model, click transformers, and it's going to give you some code right here. And you just copy and paste the code and you're good to go. Right there. It's real easy. It's real easy. Oh, WAN 2.1. I don't know about WAN. I don't know. Is that actually open source? WAN 2. There's WAN 2.2, which seems to be the next iteration of that. Models. Okay. Use this model. Libraries, diffusers. Here you go. You run pip install, diffusers, transformers, accelerate, and then you copy and paste this code, and it will give you an output video right here. Output.mb4. That's it. That's all you got to do. Real easy. Generate your video right there. Super easy. All you got to do is click use this model and then the diffusers. Copy and paste and then run that Python script. You're good to go. Thank you for the hearts, you guys. AI tool for giving the best haircut for users. Oh, that makes a lot of sense. Okay, got it. Thank you, brother. You're welcome. Absolutely. Have fun generating a man with a short gray hair plays red electric guitar. That's a prompt. I wonder what that does. All right. For Drawing Brothers, that sounds like a good idea, right? So you're going to want some sort of diffusion model, right? That's going to generate images. You're looking for the same shape in their face. So you need a data set of faces. That's going to be the hardest thing to come by, is the data set. You might be able to find it on Kaggle, maybe even on Hugging Face. Find a similar haircut. We use a GAN to apply haircut for user image. I assume that you're just going to want to get... you'll need a model that's going to understand multiple image inputs. So you're going to have... what you need to do... So this is how I would do it. I would do it like this. I would have... Let's see here. I would do it like something like this. La la la. Let me do this. All right. So I would have a bunch of haircut styles. Like, so you've got one haircut style here, right? Someone's got like fancy hair. I don't know, or like a fancy haircut style like that. And then you've got another haircut style that's like maybe just like spiky hair or something like that on their face. And what I would do is only have the hairstyle in each of these images, and you'd extract them, right? So you'd basically want to extract different hairstyles. So you'd have like different hairstyles, something like that. And then you would have a directory filled with hairstyles, and then you'd ask an image generator model to pair up someone's face with the hairstyle. That's what I would do. I don't know if it would work well. I don't know if it'd work well or not. All right, you're welcome, guys. All right, let's get back to our OpenAI challenge, the coding challenge. It's only halfway done with just the training, just the baseline. It's only halfway done with the baseline. I'm very curious to see what it's going to come out with here at the end. So what I'm going to do is I'm going to keep reading the tutorial. Once we, wait. Oh, it jumped way fast. Hold on. Oh, it's almost done. Oh, wait, no, wait. Hold on. My math was way wrong. It's not even 10%. It's only 10% done. Because that was 60. Did it? Wait, hold on. Okay, it's doing something different now. Oh, that's what it. Okay. It went to step 2. All right, so second epoch. Got it. Where are we on the loss? 6.9. Okay. That's where we're at right now. We're at 6.9. That's what happened. All right, we figured that out. All right. You know the magazines with all those pictures of different hairstyles that have someone on the barbers? Yeah, I remember that. We'd give you some to show them you want. That would be a good data set. Yes, Bonzupi, exactly. There you go. You've got your data set. Nice. Okay. For data export, rebuild instructions. Okay, so if you want to manipulate the data. Evaluation will be on RunPod environment with all packages installed. Requirements.txt is provided as a reference if you want to self-set up. We're good to go. Okay, let's read through the FAQ real quick so we know as much as we need to know about this coding challenge. What exactly counts towards the 16 megabyte artifact size? All right, thank you for the party poppers. This is a limit, so you only get 16 megabytes for the parameters, right? And it's only 16 million bytes, not 16 megabits, right? It's not like you don't get extra bytes. You only get the exact number of megabits. If you want to store prompts for different haircuts, if the shape is triangular, apply these haircuts, then show it. Oh, I see what you're doing there. Okay, so you're applying sort of a cohort or segmentation over the type and style by shape. I like that. That's a good approach. That's a good approach as well. That could help improve the quality of the output. Okay, so no external downloads, no training dataset, only access to the main training dataset, no network calls. The artifact must be fully self-contained and reproducible. Okay. Our scores independently verified by OpenAI. We're not automatically verifying every submission. We will verify the top leaderboard entries over time. Any non-reproducible results can be disqualified, and issues reproducing submissions should be raised in the PR. If you're submitting a PR and you want to note that there might be an issue when running, you have to put that in the PR. If you find an issue with the record on the leaderboard, or you find a record isn't reproducible, let us know and they will update it on the based on your findings. All right, so they're basically asking everyone to self-validate and the audience to validate as well. So OpenAI is basically not doing any work at all, is what they're saying. They're like, we're not going to do any work. However, if we find something interesting, we're going to copy it. What counts as external compute? For example, is it fair to tune my hyperparameters offline? That seems fair, right? That seems perfectly fair. To me, it does. There's no perfectly clear answer here, and it's hard to draw a clean line around what does or does not count as external compute. For now, we're reserving the right to disqualify runs that are not in the spirit of the challenge. Tuning your atom parameters across a bunch of runs is fine. If there is evidence that you're sneaking in additional compute unfairly, such as brute forcing ridiculous seeds. Oh, that was one of my ideas. I'm like, we should do a seed. We should find an ideal seed. We won't allow it. All right, well, fine. It's actually fair because we talked about this, like, what about now? At the start of stream today, we started talking about the start of the stream. I'm like, one idea is we could find the ideal seed, right? For when we generate our initial layers, we can find the ideal seed. We could. And then we could use that. They're saying that they're not going to allow us to do it. All right, fine. It's okay. Here's why it's okay. Because they are looking for something that they can use to scale up and it be reproducible in their super mega large state-of-the-art models. If you do a brute force seed, it won't count. It does not allow them to copy your approach, and it's not reusable. However, it does make the results of the competition provable and repeatable. It just is not valuable to OpenAI. Basically, they're saying, if you do something that we know isn't worth our value and we can't copy it, then we're not going to count it because you didn't give us what we're looking for. That's what it is. That's what it is. We won't allow it. Use your best judgment. There's no penalty for asking questions. Okay. What are the restrictions on evaluation? Savant, yeah, I know, right? Isn't that crazy? We won't accept submissions that take more than 10 minutes. This limit is in addition to the 10 minutes of training. Okay, so there's an evaluation phase. So you get 10 minutes for training and 10 minutes for evaluating. Otherwise, you're free to evaluate however. All right, that's good to know. The world, yeah, I know, isn't it? It's just it's a messed up world. As with modded NanoGPT, we allow evaluation of any sequence length, and obviously you aren't allowed to access any training data during evaluation. That makes sense. You can only use a training evaluation set unless you pay for those bits in the 16 megabyte limit. Oh, okay. We encourage competitors to push the bounds of evaluation methods as aggressively as with training methods. You cannot access validation data during training. Right. That seems fair. I mean, that's part of the picture, right? That's cheating otherwise, because you're just doing recall at that point by compressing it into your 16 megabyte paid prefix. If it isn't abundantly obvious, you cannot cheat on your test loss. Well, I mean, you cannot cheat by training the validation set before you evaluate on the validation set. Well, yeah, we know that. I mean, come on, we know that part. The validation language around test time training has been confusing people. You're only allowed to test time train on validation set tokens you've already evaluated in your model, since those tokens have already been graded. We know. I mean, they didn't have to say that. It's okay. What is the process for accepting new submissions? Once all submissions are public, we'll accept record submissions chronologically, depending on their PR creation time. The leaderboard may take time to update due to the verification and review submissions. So, pay consideration to what the current state-of-the-art PR is when submitting. As explained below, submissions should exceed the state-of-the-art record with sufficient statistical significance in order for it to be accepted on the leaderboard. Otherwise, submissions may be accepted as non-record submissions, given they are sufficiently unique or interesting. Okay, so you can still get some recognition if you've done something significant or worthwhile, even if it doesn't make it to the main leaderboard. I know, right? They're being very strict. Basically, they're just telling you. We know what their intentions are, don't we? We know what their intentions are. Can I import XYZ package or library? Oh, you can. Yes, you're free to import any package or library you want, as long as it does not unjustly violate the rules evaluation's computing time. Okay. Just include it in the requirements text in your record folder. Mention it in the setup instructions for your README. Since you don't pay for bits imported, the Python libraries limitations clear apply. You cannot sneak in extra compute capabilities or massively increase effective code size with custom libraries. So, but importing flash attention is completely fine. Okay. Where are we with her? Okay, where are we at here? So we are almost there. This is we're about 75% of the way there, I think. Yes, I think so. No. Maybe. Okay. All right. New records must fulfill the following criteria. They must beat existing state-of-the-art by at least a smidgen, right? So a half of a basis point. As in modded NanoGPT, because of the inner run variance, all submissions must provide enough run logs to show that the P is less than 1%, that they achieved required the half of a basis point. For submissions that improve seed through systems optimizations without challenging the ML, this requirement is waived. All right, so this is the requirement. You have to at least beat the foundation by a half basis point, and then you can submit. That's the initial requirement. Okay, that's good to know. That's really good to know. If changes are made to the tokenizer or dataset, prove with certainty that the val BPP is correctly calculated. Submissions that edit the tokenizer will be examined much more carefully, since bugs may unjustly improve your score. Oh. All right. Reproducibility run in under 10 minutes. Is that it? Is that all the requirements? All submissions must be made as a pull request that only add new folder to the appropriate records subfolder and includes the following files. Submissions without the full set of requirements will not be accepted. You need a README of submission JSON file, which includes your full name, your GitHub ID, value BPP, and related metadata. A training log automatically produced by your script. Please demonstrate a statistically significant win. Most often, submitting an average over 3 training runs is sufficient. Okay. Oh, you can do an average? Really? All right. What are we up to? Hey, how's it going there? We are looking at OpenAI's coding challenge. This is called, what is it? Parameter golf. It's called parameter golf. We put it on our Discord channel. We're running it right now. The baseline. We're running the baseline, and we're seeing what sort of score we can get on the baseline. And it takes a long time. Like, we've been sitting here for a while now. The train GPT script and any other dependencies. Nope. This must successfully compile and run with the records folder. Broken scripts are not accepted. Well, okay, that's fair. I mean, come on, that's fair. Like their hiring challenge. Yes, it's like that. Exactly. However, they say that it's a maybe. Right? They didn't say that you're gonna. It's a guarantee. They did not say it's a guarantee. They said maybe. It's not a certainty. We all see here. Wait, did we read this? Okay, so non-record submissions. Okay, so you can get some notoriety that don't count towards the record if you do some weird things, and they're still interesting. Submissions are also open to unique and interesting approaches that might not beat the state of the art, still satisfy the 16 megabyte artifact limit. We strongly encourage participants to submit implementations for weird or out-of-the-box ideas, unoptimized solutions, so long they run successfully, or even interesting negative results. We're excited to see what you come up with. We'll still maintain high bar for non-record submissions, so be sure to justify your ideas and results when you're submitting. All right, so it's got to be worthwhile. The challenge is complicated. It's actually pretty straightforward. They've got some very obvious rules that they're describing. It seems fair. Although it's not like there's not a lot of incentive here for you to just give away your ideas. You work in IT, it's always a maybe. Got to the 6th interview, oh, exactly, with the company, and then they said, I don't feel like it. I know their product enough before. I don't work for them yet. Oh, that's crazy. Really? Even after 6th interview and you know their product amazing? That's terrible. The Efron, that is horrifying. Oh, no. Wait, did I get that wrong? You work in IT as always. Maybe I got to 6th interview with the company, and then they say they don't feel like I knew. Oh, they didn't feel like they know the product enough, even after you got to the 6th interview. Okay, so even that's crazy. That's still crazy. They said I don't know enough. Okay, yeah. I mean, about their product, sure. You know enough. You could get up to speed pretty quickly about their product, though. Hey, Shiam, good to see you. Welcome on in. We're looking through OpenAI's coding challenge today is what we're doing. We're reading through it, we're understanding it to the best we possibly can, and we're running it right now. Oh, there it goes. We got it. This is the baseline. Okay, it finished. That only took like a half an hour. And that's only 1/10. And that's not even with, that's not even, there's no way. This is gonna, like, you need an NVIDIA GPU for this. Oh, thank you for the hundreds, you guys. Thank you for the hearts, appreciate it. Look at what we ran. One iteration out of 200 is what we're supposed to do. And we got 18 loss, which is way high. It's way high. It's ridiculous. Cool working with Gemini, live APIs, and live kit. Hey, very nice. All I can say, so it's good. It's good. Good to hear it. All right. This is rough, you guys. This is rough. So this is 1/10 on the data, and 1 out of 200 iterations took about 20 to 30 minutes. That's just a lot. It's just a lot to ask for. Yeah, and like, duh, I don't know the product. Of course, yeah, I don't work there. Some companies ask you to build oddly exact solutions that are extremely realistic. That's a high bar. It's a really high bar. All right, you guys, we read through all the instructions. We read it all. We read the whole thing. Except for this part right here. What is this? Training and MLX scripts are intended as good launching off points for new participants, not soda configs. We'll accept PRs that tune, improve, or simplify these scripts without significantly increasing complexity. But the best model should stay in the records folder. Okay. Okay, got it. Yeah. That makes sense. All right, you guys. Cathix. All right, so as an alternative to not having something like an H100, you could throw this on a cloud like Lambda or Google Colab. Yes. Yes, exactly. Exactly. You know it. The company, Efron, I know that, right? All right, you got a better plan. There might be a better plan. There's something better out there for you. Wow, look at this, you guys. This is crazy. Okay. Thank you for the harsh reactions, you guys. So we just read through the entire, it only took us an hour to read through this. Okay, now that we understand it, let's look through some of the code, shall we? Train GPT. Okay, so here's the script. Set wrap. All right. Scripts are intended as a good... Oh, wait, we just read that. Actually, it's actually... Okay. Hard stop. To keep readable for newcomers, let's make sure the train GPT never longer than 1,500 lines. Okay. So they let you grow it. Let's go through the main here. Where's the main at? Is this it? Main training loop. Here we go. Okay. Training time so far. Stop after. So you specify the number of steps. CUDA. All right, T0 performance counter. You are not putting the pieces together. We'll say something from the other side. I have had multiple team managers ask, are there any projects we can have the prospects do so we get something useful? Oh. Well, I definitely not exactly sure what you're talking. I feel like I should understand what you're describing, but I'm not quite getting it all the way there. So while true, there's going to be like a break in here or something. Is there a break? Right here's a break. Yeah, there's the break right there. Okay. Last step. Okay. So loop forever until you get to your final iteration. Or stopping after. Okay. Should validate. Last step. Okay. Got it. Okay. So that's what was going on. Okay. Understood. So when we ran it earlier, right here, this was the validation progress. And then we had a training. Right? I think, right? Maybe. Yes. Okay. That's so much. It's just so much. Have to go through. Okay, here it is. The beginning. Got it. Okay, understood. All right. Is WebRTC running on TCP product produces any performance except head of line blocking? UG7? Right. Yeah, WebRTC running on TCP does potentially, because TCP has a sort of, what do you call it? A slowdown mode where it can slow things down if the producer is producing more than consumer can consume, right? Producer-consumer asymmetry, right? So TCP takes that into consideration. So that way the producer, the one who's transmitting the video, will stop transmitting so much of the video packets. However, with UDP, there's no restriction on that. You just blast it. And the other side, if they can consume quickly enough, then they can consume quickly enough. If they can't, then they start dropping packets and there's no recovery. So that's why this actually works out really nicely for video. They're having the interviews do free work for them. Oh, got it, Efron. Okay, now I get it. Having the interviewers do free work for them is calling it realistic. Got it. Right. Yes, that is like an unfair thing to do in an interview, is having interviewees actually do work for your business. That's unfair. You're right. You're totally right. Sir, is it a reinforcement learning model? This is not a reinforcement model. This is just a standard, what do you call it? It's whatever is the not version of that. It's standard training. Not reinforcement. It's just standard learning. You've got the full data set. It's for some reason it's escaping me because I don't usually use that word. How's it going there, HS? Good to see you. Salvation, welcome on in as well. Happy to have you here. Actually, I'm using WebRTC with SFU, so technically not peer-to-peer. Oh, all right, there we go. Bonzupi, pre-training. We're doing the pre-training. Pre-training, okay. Yeah, that's actually a good word for it, pre-training. There's also supervised, right? Supervised learning is what I was looking for. I was looking for the word supervised training. So this is fully supervised. There's no reinforcement learning. This is just the initial supervised learning, and that's all that they're looking for. All right, last step. Val loss every and step. All right. If should validate. Watch Discord. I'm outside and can't watch stream. Hardik, what do you mean? Something on Discord, you said? Oh, hey, people are joining over here. Welcome on in on Discord. Okay. Good to have you guys here. UDP is amazing for things that are real time because you don't care about the past. Right, exactly. You don't care about the past with UDP because it just throws it away. So we're going to log our current output. CUDA, synchronize. Okay. Oh, the background soundtrack is scary. I know, Shiam, sometimes it gets to scary mode. TCP can lock up and keep trying to resend the packet. Exactly. It sure can if the consumer is not able to keep up with the producer. Supervised learning, I see. Yes. I'm actually learning how to train deep learning models these days. Nice. That's what we're doing right here. This is actually a GPT. This is generative AI. So we're currently looking through the main loop. So we've got ourselves current elapsed time, scale, which we're going to get learning rate. So this will scale the learning rate, okay, based on the current step. 0 all the gradients. 6, 7, how's it going there, Cozy? Good to see you. Welcome on in. Oh, that's why my games usually use UDP. Yeah, exactly. Bashu, wow. Oh, wow. Yeah, do you set a random seed at the top? Yes, see, I don't know if there's, there's a fixed seed. Oh, so we can't change it. All right, so this is why it's important. This is why it's important. You need to make it reproducible. You need to set the seed ahead of time. So it's not random. It's not random. It's fixed. It's right here, it's fixed. All right. Batch size, val batch size is, hold on, wait. Can Python do that? Wait, hold on. All right, 1, 2, 3, 4, 1, 2, 3, underscore 4, 5. You can do that now in Python 3. You can do that. I didn't know you could do that. I know you can do that in Rust. I didn't know that you could do that in Python. That's actually really powerful. Okay, that's a huge batch size. That's insane. Is that really what the batch size is? That can't be right. Tell me about this. What's going on here? That cannot be right. In on-prem with service mesh proxies like Istio, they don't support UDP. Oh. Well, that means that they don't support HTTP3 then, do they? They don't support HTTP3 if they don't support UDP, because HTTP3 is essentially just quick. It's quick. What percentage is the validation? 20%. We know that because we read the instructions. All right, iterations. 20,000 iterations. Warm down iterations. I'm not familiar with this strategy. I don't know what warm down is. Training batch tokens. Okay. This number is just, I've never seen a number that big before, so I'm not familiar. Like 512, okay, but this number is huge. Training sequence length, okay, so that's the input size. The max is 10 minutes. So it's like 300 seconds is 5 minutes. 600 seconds is 10 minutes. All right, the query key gain. Vocabulary size. It looks like we only have 1,000 characters, or 1,000 words, essentially, 1,000 tokens. What's with the underscore? I'm not familiar with that syntax. I know, it's neat. Check this out. You can create a number and put an underscore, and then you can put more number, and it's essentially, so watch, like, so 12 or 12. It's the same thing, right? It's pretty neat. I didn't know you could do that. You can do B's as well. 101B. Or B101. 101B. Okay. So I know in Rust you can do that. It looks like Python only lets you do so much. Is 12 to the 19 Bonzupi? It's a big number for a batch size, right? I think it's huge for a batch. Man, what is your writing instrument? For note taking or writing, like Pilot Pen or any other? I do not have I have one pen in my office and I use it like once or twice a year. That's it. I don't use any writing implements. I don't use paper. I used to though. I used to have a notebook that I walked around with in my algorithm notebook. So it's a power of 2. It's power 2. The number makes sense. I understand the number. It's a big training batch token. Okay, so it's just the number of batches that we're going to train per iteration. Is that what that means? Because what's the batch size? That's what I'm interested in. Oh, the batch size right here. It says batch size is the same thing. It's such a big batch size. I'm just unfamiliar with such a large batch size. It's huge. I think batch sizes have to be the power of 2, don't they? No, they don't. You could have any batch size you want. I've done it with any batch size. I've done it with random batch sizes. It doesn't matter that. I suppose where it does matter is depending on your GPU memory, right? Because you can only send a matrix of a certain size. When you're transmitting sort of like a texture to the GPU memory, or a matrix, right? It can only be so big. So on GPUs, they like squares, right? They like it nice and even. Because then you can fill up the entire space. So this number might be the limit for an H100. So I think that's why. I think we got our answer. Sorry, forgot in Python, it's 0B. Oh, 0B. Ah, yeah, okay, 0B. 101, 101, 101. There we go. Look at that. All right. 0H. Can we do H? How do we do hex? 0x. Yeah, there we go. Now we can get our hexagon, hexadecimal. So you got 0b for binary, and you got 0x for hexadecimal. That's really neat. If you want to represent numbers in Python, you can do that using different bases. Thank you. Thank you for saying. I appreciate it. The Efron, I appreciate it. There should be a tolerant of the underscores, and it should underscore here as well. Oh, you can only do one underscore. Okay, fine. What if I want more than one underscore though? You can do that, just not like that. Okay. Very nice. Okay. Boom, and then this should be, is this 60, what is F16? This should be 32. 15, oh, 16, okay. 16, I was off by a little bit. By 1. Are you, woman, how's it going there? Flogo, welcome on in, good to have you here. Happy Thursday. We are, man. I am very familiar with this because I am writing Risk 5 emulator. Oh, no. Efron, that's pretty satisfying. The dreaded waft by 1 error. I know, right? Von Zupi, I'm like, it's 16. Oh, wait, no, just kidding, 15. Yeah, it's essentially, because it's 0 padded, right? So it's zero indexing. So you can do 0, and then you can do F. So essentially 0 counts as the 16th. Off by 1. So triple F is 4096, right? 4096. Number of placeholders. Someone released MCP for React. Oh, there already exists an MCP for React. I'm pretty sure, right? Or are you saying someone already did MCP React? I think there is one. Refers to the integration of model context protocol within React application. Oh, to integrate MCP into React or to use an MCP to build React apps. How old are you, bro? I'm in my 40s. I am in my 40s. We are old. We're old. We're not done yet, though. We're still having a lot of fun. Currently, we're going through OpenAI's coding challenge today. It's called Parameter Golf. OpenAI's Parameter Golf. They already have a leaderboard of submissions, and we looked through a few of the submissions. It's down to signal level. Is it, Efron? You can step in the game's physics simulation layer for adding it to games like the Kerbal Space program. I played Kerbal Space many years ago. We? What do you mean we? Oh, we? What do you mean? Wait, did I say we? Did I say we? I don't know. I think MCP for React IDE in the React. Oh, got it. Okay. So, is there an MCP for building React apps? The term MCP for building React, yeah, blah, 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 blah. I want to know if there is one. It says interactive MCP. This is showing how to use an MCP inside of a React app. It's not showing you an MCP for React, though. Oh, yes, you said we are old, and I'm like, what do you mean by that? Well, okay. So, sometimes I use the word we when I mean, okay, I messed up. I'm trying to justify. I cannot justify that. I just messed up. I am in my 40s. My goal is to make it so that people can use realistic system in the games so that they learn real stuff instead of just the Lua. Ooh, nice. Beyond the Lua scripting? That sounds really useful. That's really useful. You could use Cursor or Windsor for IDE. I use Vim. It's my favorite. Because I can do whatever I want in my terminal. I can do whatever I want. Go back on previous results. This is right here. As far as I can tell, this is just ways building MCP clients. I don't know about this. I'd have to search for longer. There's also MCP registries, so you could go look there as well. It's the royal we, exactly, Bonzupi. You don't know about others. I am old. Hey, I'm old. I count as I'm being old. I'm old, you guys. I am the other in we. Oh, exactly. Nice. All right. We're old together. Create an MCP server mounted on fast API application. Yeah. Lua is real. I love Lua. NeoVim config is Lua. Yes, exactly. So there is NeoVim, which is just standard Vim with Lua scripting added onto it. Because it's nicer. Lua is nicer than Vim script. It's nicer. Understood. I use standard Vim though. I don't need to add any custom crazinesses to my Vim. Second link from start, storybook. Storybook MCP for React. Agents don't know anything about your components. Oh, this is it. Storybook MCP. All right, you found it. You found it, Claude. Very nice. That was it right there. Good job, Claude. What are you doing at the moment, bro? Which programming are you using? So this is Python. We're running PyTorch. We're doing a lot of PyTorch this month and next month. Lots of PyTorch. We're currently looking at OpenAI's coding challenge, which is right around here. Here it is, called Parameter Golf. They let you submit your code for the challenge. What does Story MCP book do? So Storybook MCP is an MCP server that gives your AI context about your components and instructions to write stories and preview the work, ability to run tests and fix. Okay. Share UI components. Publish your Storybook MCP server to share components. Okay, so what this does, I believe, is what I'm reading it as. You can build an MCP that understands your components. Agent self-verify. Add the MCP server to your client. I don't know if this is exactly what we thought it was. Is a server that connects your Storybook to AI agents, allowing them to understand your components and documentation, generate stories, run tests, and more. Agents will be required to reuse your existing components and follow your documentation guides. Okay, so this is a good way to, if you have an existing React application and you have components that you've built custom, to have your AI agents conform to that. That's what that's for. Hey, Anastasia, good to see you. You're in late. Hey, no worries. Good to have you here. Happy Thursday. We are learning the Parameter Golf, OpenAI's coding challenge. We're looking through all the source code, and we read through all the rules already. So we read through the rules. So that's the part you missed. Don't worry. All it is, you have to make a model improved better than a certain baseline. A half of a basis point is the improvement that you need as the floor to submit your model for the loss based on the baseline. Essentially, you need to make a better model, and you can only do it in certain ways. They've got restrictions, and you're limited to 10 minutes on GPU compute. So that's it. Thank you, man. Always a pleasure to help. Yeah, thank you. I'm in your new startup. Oh, exactly. Or whenever you start. Yeah, we haven't started it yet. It might be a while. Please place me. All right. You're the man. All right. You're the man too. Thank you. Doesn't your source code give that context? It sounds like they're having you work for free. They are. They are having you work for free. The Efron, this is exactly what's happening. The Efron. Wait, hold, let me say your name again better. Eforin. The Eforin. Okay. The Eforin. I'll try. I was saying your name wrong. Or the F-Orin. F-Orin. Yes, exactly. F-Orin. All right, the F-Orin. So yes, you're right. They're having us work for free. And we're falling into their trap right now. It's a trap! We're doing it anyway! It's a trap! Efron. I know, I thought it was Efron. All right. All right, so our query key gain init. We're trying to say foreign slowly. Is that what it is? Foreign. Yes. It's the game trap. It sure is, Anasazi. So our vocabulary size is 1024. 9 layers, 4 heads. Number of heads it doesn't mean anything special other than the parallelization that's occurring. So if you want to increase your parallelization, you can do that. Although I don't know if there's a risk on this if you've got like a lot of CPUs. So you might want to jump that higher. Though there's a diminishing returns and potential penalty if you do. Dimensions. So this must be the dimensions per layer. Number of heads. Okay. MLP molts. Tie embeddings. Rope base. So there's a whole bunch of terms here that I'm not super familiar with. That got there. Hey, bingo. We got there. We got there. The soft cap. Okay. Optimizer hyperparameters. Okay, so now we're in our optimizer, which is a... Was it... They said something about a cross... Let's see, hold on one second. Let's look at this real quick. What was that optimizer at? Let's see, cross entropy? Where was it? Where was it? Is this the right one? Was that the loss? Validation loss? Where was that at? Given constrained, blah, blah, blah. Loss. Where was that? Was it loss? Was it opt? I'm trying to find it. Have you heard of OpenAI closed source? Yeah, I just heard about that. Yep. They're turning off the video generator. If you used it and you liked it, you don't get it anymore. Although I think you had to pay for it, right? You had to pay for it. I'm planning to learn MicroPython and program the new ESP32 chip. Ooh, yes, that sounds like a really fun project. Where was the cross at? I saw the word cross. Entries. Valid. Validation loss, quickly as possible. Print, okay, yep, okay. Oh well. We'll run into it later. Hey Jinlu, good to see you. You used it for free for a while, then they made it paid. Oh, got it, okay. They made like $1 million or something. They had to have made more than that. MicroPython is fun. It made component for an escape room. Oh, really? Oh, nice. Okay. So use some MicroPython and some sort of embedded compute to build a puzzle into an escape room. That sounds awesome. Like maybe number of door knocks or something. Hello? Man, you notice something I see here longer than usual. You noticed something you see here longer. Yeah, you are here longer than more recent. Yep, over the last few days you had to head out early. All right. So we got our learning rate, another learning rate, tied embedding learning rate. So we got multiple learning rates here. We've got our init standard deviation. Is that what we're doing here? They made million by spending more than $1 million. Yeah, they sure did. They did. They've had to have. So it came with ChatGPT and Codex for $20. That's not bad. Okay. That's a pretty good deal. It really is. This is a good deal. Bro, love your energy. Hey, thank you. Appreciate it. Marcio, is that how you say your name? Marcio Ferreria. Thank you for being here. Hey, you're welcome. Happy to be here. Learned so much with all you and the people in your channel. You're all amazing. I love you guys. Hey, that's great to hear. Thank you. That's what we're here for. We're learning together. You guys. Ultrasonic robot. Oh, got it. Okay. That sounds like a really interesting component in an escape room. You used pilot pins. Yes. Also, which pin you have just for... Which pin you have? I just forgot, man. I don't know. Let's find out. It's going to be one pin. I only have one pin. Here it is. It's a big... you can't see it really well. That's it right there. It's the only pin I got. And it's the only... It's like a 15 years old or something like that. It's a 15-year-old pin. And it still works perfectly fine. Because I don't use it very often. What are we making? Hey, Danny, how's it going there? We are going through OpenAI's parameter golf. It's a coding challenge. We have until the end of April to submit. That's what we got. End of April to submit. Yeah, I made a game component that was a wire plugin puzzle on ESP32 and would randomize the solution, providing the current solution and the endpoint to trigger commands to change or set the code. Nice! That's really neat. Okay, so it allows and it prevents cheating because the answer is always going to be random. That's a good idea. Microslop Kane with Microslop for $20. Super deal, yeah, right? Mind's mouth. Pay $20, you get the slop generator. Whoa, nice one, man. What are you guys doing? Sounds nice. Yeah, that's what we're doing. We're doing parameter golf right now. We're reading through the tutorial for setting it up. We did that. We got through that part. We did all the FAQs. We understand the competition now. We have a full understanding of the competition. What we need to do next is read through all of the baseline. We're reading through the baseline right now is what we're doing. Yeah, the big crystal pin. Hey, Jin Lu is the pin so many people can write nowadays. Before that pin existed, only 30% of the people could write. Really? No way. It's because of the BIC, you guys. Add replayability. Yeah, so you can go back and the puzzle will be different next time. Got the replayability in there. Okay. Momentum, back steps, warm up, and warm up steps. Then we got some sort of beta parameters. Atom ESP. Where's our optimizer? It's an atom. All right, so what is ESP in atom? Let's find out. We're gonna find out. You haven't written in so long? I know. I'm gonna write later this month. Yeah, I probably should this weekend to do some taxes, things I have to do in taxes. In program, yes, I know about NAN, absolutely. Good or bad for smart working, get others office programs. So it's actually Flogo. Hey, Flogo, good question. NAN is pretty great. I think it's great. A nice way to create a pipeline that is reusable. It's a really good way to create a pipeline that's reusable. And it comes in a Docker file, so you can run it locally. It's an open source. It's great. NAN's fantastic. You're that 30% person who is first right, then action. Okay, got to be the 30% person. Optimizer. So we got another optimizer. The optimizer token learning rate. What is ESP in Atom? ESP Atom. What is this? I've not used ESP before. ESP Atom optimizer. The adaptive momentum estimation optimizer is a popular algorithm used for deep learning. It's an extension of stochastic gradient descent. Yeah, I like that one. Computes individual adaptive learning rates for different parameters, making it highly effective for complex, high-dimensional, and sparse optimization problems. What is the ESP part of it? What is ESP? Where's that at? We need to know the ESP part. What is ESP in Atom Optimizer? What is that? Oh yeah, more like SGD. Yeah, stochastic gradient descent. That's the one I use. That's the one I use in my algorithms. I like it. In the context of Atom Optimizer, ESP is most likely refers to the what is that word? Sawtooth phenomenon. Oh, got it. When it's converging on the local minima. Specific training patterns identified for recent machine learning researchers. Okay. If you meant did I mean EPS? Yes, I did. I did mean EPS. I did. Okay, so I typoed it. I meant EPS. Got it. EPS. If you were looking for a configuration parameter, you likely meant EPS. Epsilon! Oh, epsilon. All right, that's just a small number. That's all that is. All right. We should rewrite a script that help with creating holograms. Ooh, create some new holocom. Epochal, right? That's how I say that word. Oh, wait, epsilon? You say that word epochal? Wait, no, there's no way. Epsilon, it's epsilon, right? There's no way that's epochal. No? Okay. So that's something different? Oh, this one, apocal. Sawtooth phenomenon. Got it, apocal. Ah, yes. So apocal sawtooth phenomenon. I understand that because you're diverging on your local minimum. Bingo, right there. Sawtooth pattern, yep. I know what that is. It's primarily driven by the second momentum estimate as a parameter that happens when data loaders shuffle the dataset start to a new epoch. Well, it looks like a lack of convergence is often a byproduct of how optimizers adapt to fresh data. Okay. And not a sign of overfitting. That seems fair. It's an epoch at the epoch level. Yeah, exactly. All right. So we understand epsilon now. I get that part. Where is our epsilon at? Yep, right there, epsilon. It's a small number. This is the epsilon I use. I use this epsilon too. This is my normal epsilon. When I use epsilon, I use this epsilon. It's interesting that they're using it directly here. Okay. Grad clip norm. All right, so 0. Because we're using ReLU, right? Okay. So that's the type of parameters. All right, where are we at here? All right, you guys. We got about 14 minutes left, and we're gonna keep on going. We're gonna keep on looking through all of the different concepts here. We're gonna walk through each of them, and we're gonna try to understand what's happening the best we can. Okay, so the epsilon basically is helping in handling a small loss happens of start of the epoch. Oh, Danny, is that? I'm not sure. Well, where I use it is in a couple places. When I use epsilon, I'm using it for the weights. For the most part, the weights themselves. When I'm generating them initially. And the gradients. I use them in the gradients as well. So I don't know where they're being used. They're being used in the Atom Optimizer right now. So this is basically saying what your floor is. What are you making? This is OpenAI's parameter golf. It's a coding challenge where they want you to make an improvement to the baseline model using various tricks and tactics, and hopefully looking for a novel solution that improves how fast they can train AIs. And you get no prize. There's no prize. You just give your ideas away. That's basically all this is. Give us your ideas. Optimizer. So we've got multiple optimizers here. We've got a token optimizer, and we've got a Muon optimizer, and we got a scalar optimizer. So we've got multiple optimizers. Here is a list of all of them. All right. You use the @ symbol for matrix multiplication? Yeah, there we go. That's my favorite one. That's my favorite operator. It's so good. I love it because it gives you so much. That @ operator is like a multiple for loop, right? It's an embedded for loop, multi-step for loop, and it allows you to also run transpositions automatically, I think, right? Maybe. I think it auto transpose. I think there's an auto for matrix multiplication. It's nice. It's like an all-in-one, one character super operator. All right. So we got a list of optimizers. If base model ML head is not none, you've got your head optimizer, and then you've got a list, and then you've added. Okay, so you've increased your optimizer. So this is interesting. They're using multiple optimizers. I didn't know that you could. You're not familiar with the @ symbol? It's pretty great. Check this out. I love it. All right, so import numpy as np. So np.array, I believe. We could do nd array, something like that. 3 by 3. Can we do that? How do we do interpret 3? Do we have to do it in this? Here we go. All right, so there we go. Nd array, and then you can say a equals, and then b equals, and you can say a at b, and then it matrix multiplies a and b is what that does. It's a really nice operator, and it only works if it's already been built in. It's a dunder method, right? It's a dunder method, so it only works in if the framework supports it. You can't do that with native arrays, right? 1 by 1 at 1 by 1. That won't work because it's not a defined operator. You have to use it in PyTorch or in NumPy. That's what you have to do there. Love the magic. That was the baseline model. It's a pretty good baseline model. And I'm really curious about the multiple optimizers. It handles broadcasting too. Yeah, that's a good point. It sure does. How is it different than multiplication? Let's find out. Watch this. It's slightly different. Here, so multiplication, and so one's a dot product and one's a multiplication. It looks like, yeah, it's a different order of operations. So I think there's auto transposition. Is there on A or .t? Where that at? Okay. Yeah, that's actually a really good question. I'm trying. There's definitely a difference. You can see there's definitely a difference because the outputs are different. You can see the outputs are different between the two. So there is a difference. That would probably make sense if I knew matrix math. Never got around to learning it. It is not what I wanted. It is weird. Don't get me wrong. It is weird because you have to do these. The stepping is weird. Because when you're doing a matrix multiplication, you take each cell and multiply it with all the other cells. And then it creates a new matrix. And I think there's some addition involved. I forgot about it. I'll have to look back into that. So there is a difference, although as you can tell, it's just order. I think it's a difference of order. Let's see here. NumPy difference between operators. Okay. Perform different types of multiplications. Okay, so it is multiplication. It is. The operator performs an element-wise multiplication, whereas the at operator performs a matrix multiplication. The dot product. I see, I told you right there. The dot product, following the rules of linear algebra. Otherwise, the star operator performs element operators, which is the Hadamard product. All right. Meaning each element in the first array is multiplied by the corresponding element in the second array. Okay, got it. Understood. A, B. So, if we do... Okay, yeah, okay, got it. Oh, it's a direct. Exactly. Matrix multiplication and GLSL is even more confusing. Oh, Jinlu, we're getting into it. So you can do numpy.multiply for the star operator, or matmulp or dot for dot product, or matmulp. So that's the difference as far as I can tell. Must be compatible. Inner dimensions must match. So the inner dimensions must match. You can have a different outer dimension though. Unless you set it to 1. The inner dimension can also be 1 for broadcasting. So like if you have a 2 by 2, then multiply it with a 3 by 3, it'll give you a 6 by 6. Oh, 6, 6. Yeah, okay, let's try it. Let's do np.array. We'll say a 2, 2, right? So that's A. B. Well, B will be 3 by 3. 3, 3. Let's try this. A times B. Boom. 6 by 6. Hey, look who's right over there. Look who got it right. No. Yes. You got it right. What do you mean no? Same size. Same size? What do you mean? You got the 6 by 6. Oh, you got it right. Bye, Steven. All right, Claude. Good to see you. We'll see you tomorrow. Yeah, that's it right there, right? It is the same size. It's the same size. It's a misunderstood. Yeah, you did it right there. And then let's see what at does. It's a dot product, right? So it's going to give you either a matrix or a scalar. You thought I made it 3 by 3. Oh yeah. So I made it, right, exactly. Understood. Cool beans. You got it right. You got it right. So you get dot product or the multiplication element wise, which is going to give you always an output. And you want to do dot product when you're doing specifically, or matrix multiplication, right? Dot product approach when you're doing AI, because it allows you to broadcast into the output results to match your desired classes that you're using. The dot shape, yep, exactly. The dot shape, you got it. And B, the same size. Boom, same size. Yeah, that's why I didn't use ND array, because ND array will give you a different result, I believe. Yeah, so that's a 2x2 rather than a 2x1. CEO was following everything until you said broadcast. Oh yeah, broadcast. So broadcast is something that we learned in the PyTorch tutorials a couple of days ago. It's actually pretty straightforward. So let's say we've got our B. Let's say B, I think 10. We can say 1. And we say A. It was the same thing for A. A, right? So you can do A times B, and that works. A at B. Won't. Because you have to transpose it. There you go. And that's because the inputs can't match when you're doing the dimensions of the operations. Don't match. You have to transpose it if it's not equal otherwise. Obviously, if you have a square, it'll work without transposition. And let's see. Let's do ones. Can we do ones? Can we do dot ones? Yeah, there we go. A, B, 10, 10. Which I think here you could do this. So A is going to be at a batch, right? So this will broadcast it, right? So there's A, and then B is going to be this. So here's a broadcast situation, right? I think you can do A times B. Does this work? Yes, there you go. So that's a broadcast. So you can see that there are different shapes and different dimensions right there. So the broadcast allows it to sort of repeat. So it says repeat this 10 times, essentially. So that's one of the broadcast approaches. You know, it's pretty interesting if you think you can improve even a little bit of OpenAI's base model. It's a big thing, no lie, is it? I have some ideas. And really the idea is all about compute time. So that's the main point. They want to constrain the compute time. So you get 10 minutes. You can improve the algorithm and get lower learning rate by squeezing more of the compute within 10-minute window. You can do that if you do a mega kernel. You can do it if you do a mega kernel. You certainly can. You certainly can. And I think that's a way to do it. Also, if you add in some... I wanted to do a randomization in it, though they say that you can't do that. I was like, oh, we're going to do random seeds, and we're going to find the best seed, and we're going to cheat the system. Apparently, that's cheating. You can't do that. You can't do that. So, that's one of the challenges. Okay. All right, you guys. Let's see what we got here. So, let's look a little bit more through some of the code here real quick. So, this is interesting. I like how they're using optimizers. All right, so zero all the gradients and all the optimizers. Set to none, true. That's neat. So we got our optimizers. This is neat. So they're applying multiple optimizers all at once. I didn't know. I never even thought to try that. That's a really neat idea. It's really neat. Randomization would have solved the problem. It really would have. I certainly would. What they're looking for is something reproducible when they scale it up. So if you find a seed that works really well for a fixed sized model, it will not transfer, is what it is. So they'll scale the model up and that seed is no longer valuable. That's what that's about. That's all that's about. This is neat. I like this. Initial optimizer state, deep copy. Okay, warm up steps. So doing some warm up steps here. For what reason? I don't know. I'm not sure. This must be something related to the hardware. I'm not familiar with the warm-up phase. Let's see if we can learn about this real quick. Warm-up phase in AI training. What is this? What is it? So they don't need... They do. Seed. Oh, they don't... They fix the seed right there. So here's the fixed seed right there. Danny, right there. They got a fixed seed right there. And you can change it, though they're going to penalize you. They're going to discount your submission if you change it. They allow you to. They just won't let you submit on the real leaderboard. It's not the real leaderboard. The warm-up phase in AI training, a technique where the learning rate starts very low and gradually increases. Yeah, I know about that. Target rate during the initial training. It stabilizes the early training by preventing massive disruptive weight updates. Oh, so it is part of the training phase. They just reduce the learning rate. Oh, okay, now we figured it out. All right, now we know what this is all about. Wait, where's that go? Oh, the warm up here. Now we know. Okay. Normally, they do random, I'm sure. For this, they want better code, not better luck. Exactly. You got it. All right. Zero power via Newton skulls 5 as borrowed from modded NanoGPT. Background on Muon. All right. Let's take a quick look at this background here. Whoop. Copy. And paste. Dark mode thing. All right. An optimizer for hidden layers in neural networks. So I think what we're going to do is we might save this for tomorrow and we'll look at, look at that, nice and smooth. Oh, look at that smoothness right there. Oh, that's so good. All right, so ABX, all right, sounds good to me. Hey, Steven, hey, how's it going? We are about to wrap up here. If you guys have any last questions, let me know. This is the plan for tomorrow. I believe we're going to go through the Muon, an optimizer for hidden layers in neural networks. I think that's the plan for tomorrow. And then we will continue on after that with our AutoGrad. We'll continue on with AutoGrad. You are going to have lunch with wife. Oh, what? Really? Was that a thing? All right. Shravant. Hey, good to see you. All right, you guys. The plan for tomorrow, we're going to go through Muon, an optimizer for hidden layers in neural networks. That's the plan for tomorrow. It was so good to have you here. Thank you for joining in. We will be back tomorrow. More AI, more PyTorch. How can I join Cognition team that is building Devon AI? I don't know. Are they even hiring? Thank you. All right, Vasu, thank you. See ya, Danny. Good to have you guys here. Appreciate it. I had a lot of fun today. We went over the entire GPT parameter golf. We know everything we need to know about it. We understand it. We need to continue on the rest of the understanding of the baseline, which is 1,000 lines of Python code. So we need to there's a lot of code here. There's a lot that we gotta get through. We understand it. I love it. It's great. They're using multiple optimizers and they're using a warm-up phase. Oh, it's just so good. There's so much good, beautiful things in here. I love it. Hey, it's been a long time to see you. Hey, Jump Buster, good to see you. Welcome on in. Are you married? Nice to know. We are not. We are not married. We are single. Someone is just trolling. We're just getting troll. We got troll activity. The good old troll, the rizzing, you guys. Got some riz. Thank you guys, 100. Good to have you here. We'll be back tomorrow. Appreciate it. Bye, everybody. See you tomorrow. Have a good rest of your day.